7.5 goes over solving equations with radicals and with exponents. The first part that we are going to be looking at is solving equations by taking the square root, the cube root, the fifth root, the sixth root, fourth root, any root. If we look at example 1, we're just told to solve each equation. For example A, we have x cubed is equal to 27. As long as our variable that's raised to a power is isolated and there's a constant on the other side of our equal sign, we can take the root of the power that variable is raised to on each side. Only thing you have to remember with these is if your power is even, so if it's 2, 4, 6, 8, so on, if you take that root of both sides, a plus or minus has to go in front of your answer. If it's odd, doesn't need it. So if we look at example A, we have x cubed is equal to 27. Because that power is 3, we're going to take the cube root of each side. That x cubed, the cube root of it is just x. The 27, we have 3 and 9. 9 is 3 and 3. So we have our group of 3. We pull 1 out. So x is equal to 3. For example B, we have x to the fifth power plus 32 is equal to 0. For this one, we're going to subtract the 32 from each side in order to isolate that x to the fifth power. We have x to the fifth power is equal to negative 32. From here, we're going to take the fifth root of each side because our power is 5. That fifth root cancels out our power, so we'll just have x is equal to that negative 32. There is a negative underneath there. Our index is odd. We're okay. Our answer is just going to be negative as well. That 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. 4 is 2 times 2. We're looking for a group of 5. We have a group of 5. So x is equal to negative 2. Again, remember, because there was that negative underneath that radical, it's going to be with our answer since our index is odd. For example C, we have x minus 2 cubed is equal to 24. Our x minus 2 cubed, our term that's being raised to a power, is isolated. So we're going to take the cube root of both sides. From here, that cube root cancels out the power, and you're just going to have x minus 2 on that left side. That 24 is 4 times 6. The 4 is 2 times 2. 6 is 2 times 3. So we're going to pair up those 2's or group up those 2's and just have x minus 2 is equal to 2 cube root 3. From here, we add that 2 to move it to the other side, and we get x is equal to 2 plus 2 cube root 3. With these, your constant, so the term that doesn't have the variable or the radical attached to it, will go in front, always. Just like if there was a plus or minus in front of it, that constant goes in front of the term that has that radical. The next part of our lesson goes over these even root properties. So again, like what I mentioned in the beginning of our lesson, if our power is even, we're taking the square root of both sides, the fourth root of both sides, the sixth root of both sides, so on. Your plus or minus will go in front of your answer. Additionally, you cannot have a negative underneath the radical that has an even root or an even index. So if we look at example 2, we're just solving these equations. For 2a, we have the square root of the x squared is equal to 10. We're going to take the square root of both sides. You cannot simplify that 10 any further than it is because its only factors are 2 and 5. So we're going to have x is equal to plus or minus the square root of 10. If that plus or minus is not included with your answer for this, it is considered to be wrong. So please make sure that that plus or minus goes in front of your answers when you have ones like these. For example B, we have w to the 8th power is equal to 0. So we're going to take the 8th root of both sides. Any root of 0 is just 0, so w is equal to 0. And you do not have to put the plus or minus in front of the 0 because 0 is neither positive nor negative. So again, it's just the 0. That's your answer for this one. For example C, we have x to the 4th power is equal to negative 4. So we're going to take the 4th root of both sides. That x to the 4th power, the 4th root of it, cancels out that power. With the 4th root of negative 4, you have a negative underneath there, and you cannot have a negative underneath a radical that has an even index. So this would automatically be no solution. For our next part, we're still just solving these equations. For example, 3a, we have x minus 3 squared is equal to 4. The term or the part that is being raised to a power is isolated, so we're going to take the square root of both sides. That square root cancels out the power to where we just have x minus 3. The square root of 4 is positive and negative 2. So now with this, we do not have a radical left over, so we're going to simplify it as two different equations. So we're going to have x minus 3 is equal to negative 2, as well as x minus 3 is equal to positive 2. We're going to add the 3 to both sides for each of these, and we get that x is equal to 1 and x is equal to 5. So two answers here, the 1 and the 5. For example B, we have 2 times x minus 5 squared minus 7 is equal to 0. We want to isolate that x minus 5 squared, so we're first going to add the 7 to both sides. This gives us 2 times x minus 5 squared is equal to 7. From there, we're going to divide each side by the 2. Those cancel, so we just have x minus 5 squared is equal to 7 over 2. From here, we're going to take the square root of both sides. Remember to put the plus or minus in front of your answer. You cannot simplify the square root of 7. You cannot simplify the square root of 2. So before you go any further with this, rationalize your denominator. Multiply the top and the bottom here by the square root of 2. So we're going to be left with x minus 5 is equal to plus or minus the square root of 14 over 2. From here, you can add the 5 to both sides. It goes in front of that plus or minus square root 14 over 2. If you also wanted to write this with like denominators, you would multiply the 5 by 2 and put it over 2. So this would just be x is equal to 10 plus or minus the square root of 14 all over 2. So either one of these is fine, either this one or that x is equal to 5 plus or minus the square root of 14 over 2. That just has the square root of 14 over 2. For example C, we have x to the 4th power minus 1 is equal to 80. For this one, we're going to start by adding 1 to both sides to isolate that x to the 4th power. We have x to the 4th power is equal to 81. We're then going to take the 4th root of each side. That 4th root of x to the 4th cancels out the power, and you're just left with x. That 81 is 9 times 9, and 9 is 3 times 3. We need a set of 4 to pull 1 out. We have that. We put the plus or minus in front of our answer since we're taking the even index or the even root of this, and we get that x is equal to plus or minus 3. For example 4, we're solving equations that involve radicals. When we have radicals in our equation, we're going to isolate the radical and then raise each side to the power that is with the, or that is the index. So with example 4, we have a couple different examples with these. The first one that we're going to look at only has one radical in our equation. For example A, we have the square root of 2x minus 3 minus 5 is equal to 0. So first we want to isolate that radical. So we're going to move that 5 over by adding it to both sides. This leaves us with the square root of 2x minus 3 is equal to 5. we're going to raise each side to the same power that is our index. We don't have an index here, so it's understood that it's a 2. So we're going to raise each side to the power of 2. Raising that square root to the power of 2 cancels out the radical, and you're just left with what's underneath, which is the 2x minus 3. The 5 squared is 25. From here, we just solve for x like a normal equation. We're going to undo addition or subtraction before we undo multiplication or division. So we're going to add the 3 to both sides. We get 2x is equal to 28. Then we divide each side by the 2. And we get that x is equal to 14. For example B, we have the cube root of 3x plus 5 is equal to the cube root of x minus 1. So in this case, we have the radical on both sides of our equation. That's perfectly fine. We don't have any term that is not underneath the radical. So we're just going to raise each side to the power of our index, which is 3. This cancels out the radical on both sides, so we just have the 3x plus 5 is equal to x minus 1. Solve it like a normal equation. Subtract the x from each side. You have 2x plus 5 is equal to negative 1. Move your 5 over, subtract it from each side. You have 2x is equal to negative 6. Divide each side by the 2, and you have that x is equal to negative 3. For our next example within this section, we have the square root of 3x plus 18 is equal to x. For this one, again, we're going to raise each side to the power of our index, which in this case is 2. That power cancels out the radical, so we have 3x plus 18 is equal to x squared. Right now, our x squared is positive. We want to keep it positive. So we're going to move the 3x over by subtracting it from each side, as well as the 18 over by subtracting it from each side. So we have x squared minus 3x minus 18 is equal to 0. From here, find your factors of negative 18 that add up to be negative 3. You have 3 and negative 6 that multiply to give you negative 18, but combine to give you negative 3. So this factors out to be x plus 3 times x minus 6 is equal to 0. Now that you've factored this, set each part equal to 0 and solve for each of them. Move your 3 over by subtracting it from each side. You get x is equal to negative 3. Move your 6 over by adding it to each side. You get that x is equal to 6. So negative 3 and 6 are your two answers for this one. For example 5, we are told to solve the square root of 5x minus 1 minus the square root of x plus 2 is equal to 1. For this, we are going to square both sides in order to get rid of the radical, or at least try to get rid of the radical. When we do this, the reason why we are squaring both sides is because both of those indexes are 2. So we're going to raise this side to the second power. We're going to raise this side to the second power. We have a binomial squared, so we can use our perfect square trinomial formula. So a squared plus or minus 2 times a times b plus b squared. We'll use that minus 2 times a times b since there's a subtraction sign between these two radicals. So we're going to have an a of that square root of 5x minus 1, a b of that square root of x plus 2. This gives us the square root of 5x minus 1 squared minus 2 times the square root of 5x minus 1 times the square root of x plus 2 plus the square root of x plus 2 squared is equal to 1. When we square that square root of 5x minus 1, it cancels out the radical and the power, and we're just left with the 5x minus 1. that negative 2 times the square root of 5x minus 1 times the square root of x plus 2. That negative 2 is going to stay on the outside. Inside, we are going to multiply the 5x minus 1 times the x plus 2. Then we have that square root of x plus 2 squared. The power cancels out the radical since they are the same index and the same power. And we just have x plus 2 left from that. And it's still equal to 1. From here, we can combine our like terms on the outside of that radical as well as FOIL the inside of that radical. So on the outside, that 5x and that x are like terms. That gives us 6x. The negative 1 and the 2 are like terms. That gives us a positive 1. We don't do anything with that 2 in front of the radical because it's being multiplied by the radical. So leave it in front of the radical. Do not combine it with anything else. The 5x times x is 5x squared. 5x times 2 is positive 10x. Negative 1 times x is negative x. And negative 1 times 2 is negative 2. This is all underneath our radical. And now we are equal to 1. From here, we're going to subtract the 1 from each side to move over anything that's not the radical. So we have 6x minus 2 times the square root of 5x squared. We're going to combine those like terms underneath. Plus 9x minus 2 underneath that radical. And that's equal to 0 now. From here, you want to move that 6x over, so we're going to subtract it from each side. This leaves us with negative 2 square root 5x squared plus 9x minus 2 is equal to negative 6x. From here, you want to divide each side by that negative 2 in order to, again, isolate that radical. So we have the square root of 5x squared plus 9x minus 2 is equal to 3x. From here, we're going to square both sides of this in order to get rid of that radical. So we square the left, we square the right. Squaring the left cancels out the radical and the power to where we just have the 5x squared plus 9x minus 2 is equal to the 3x squared. That 3x squared is 3x times 3x, which is 9x squared. From here, my bigger x squared coefficient is that 9x squared. So I'm going to move everything over to that 9x squared in order to give me a positive a value on x squared. So I'm going to subtract the 5x squared from each side, subtract the 9x from each side, and add the 2 to both sides. So that's minus 5x squared minus 9x plus 2. These all cancel, and we're going to be working with 4x squared minus 9x plus 2 is equal to 0. From here, try to FOIL in order to solve, try to factor in order to solve. If you were to factor this, you can multiply the 4 times 2 to give you 8. The factors of 8 that add up to be a negative 9 are negative 1 and negative 8. So we can factor this to be 4x squared minus x minus 8x plus 2 is equal to 0. We have 4 terms, so we factor by grouping. Factor out an x from the first set, factor out a negative 2 from the second. This is going to leave us with x times 4x minus 1 minus 2 times 4x minus 1 is equal to 0. From here, your 2 sets of parentheses are the same. So this gives us 4x minus 1 times x minus 2 is equal to 0. Set each set of parentheses equal to 0 now and solve for both. So we're going to have the 4x minus 1 is equal to 0 and the x minus 2 is equal to 0. Move your 1 over by adding it to both sides, and that 4x minus 1 is equal to 0. You have 4x is equal to 1. Divide each side by the 4, and you get that x is equal to 1/4. Your other equation, you have x minus 2 is equal to 0. Add the 2 to both sides. And you get that x is also equal to positive 2. So two answers here, one that's 1/4, the other that is 2. For example 6, we're solving each equation. These we are working with rational exponents, which means our fractions are part of our powers, or our powers include fractions. If we look at example 6a, we have x to the power of 2/3 is equal to 4. Rewrite this using radical form. This is going to give us the cube root of x squared is equal to 4. We want to get rid of that cube root to start with, so raise each side to the power of the index, which is 3. That cancels the radical and the power out, so we just have x squared is equal to 4 cubed, which is 64. From here, take the square root of both sides. That square root cancels out the power on x, so you just have x, and the square root of 64 is 8. We did take the square root of both sides, so we have to put that plus or minus in front of the 8. For example B, we are given w minus 1 to the power of negative 2/5 is equal to 4. This w minus 1 to the power of negative 2/5, you want that power to become positive. So take the reciprocal of that w minus 1. So it would be 1 over w minus 1 to now the positive 2/5 power is equal to 4. From here, I would rewrite this as a radical or in radical form. So we have 1 over the 5th root of w minus 1 squared is equal to 4. From here, I don't want that radical in the denominator of our fraction, so I'm going to multiply each side by that 5th root of w minus 1 squared in order to cancel it out on that left side. So this is going to leave us with 1 is equal to 4 times the 5th root of w minus 1 squared. From here, I have 4 being multiplied by this radical. Instead of multiplying it, we're going to divide it on each side to move it over, because I don't want it to be next to or multiplied to that radical. So this is going to leave us with 1/4 is equal to the 5th root of w minus 1 squared. In order to cancel out that radical, we need to raise each side to the power of its index, which is 5. Those 5s cancel out. We have 1/4 to the 5th power. That 4 to the 5th power is 1024, so that's 1 over 1024 is equal to w minus 1 squared. From here, we just take the square root of both sides. That cancels out our power with that w minus 1, so we just have w minus 1 is equal to the square root of 1, which is 1 over the square root of 1024, which is 32. We took the square root of both sides, so our plus or minus goes in front of that 1 over 32. That 1 over 32 does not have a radical left with it, so we're going to separate this into two equations. We're going to have w minus 1 is equal to negative 1 over 32, as well as w minus 1 is equal to positive 1 over 32. In order to get w by itself, we're going to add 1 to both sides, which is the same thing as 32 over 32. We do this for both of these equations. The ones will cancel. We are left with w is equal to 31 over 32, and w is equal to 33 over 32. For our last example, example 7, we have 2t minus 3 to the power of negative 2/3 is equal to negative 1. First thing, make the power positive. Take the reciprocal of the term that's attached to. So we're going to have 1 over 2t minus 3 to the power of now positive 2/3 is equal to negative 1. I'm going to turn this 2t minus 3 to the power of 2/3 into radical form. This is going to give us 1 over the cube root of 2t minus 3 squared is equal to -1. From here, I want to get rid of the radical in our denominator, so I'm going to multiply each side by the cube root of 2t minus 3 squared. These are going to cancel out on the left side, so that way we just have 1 is equal to -1 times the cube root of 2t minus 3 squared. We don't want that -1 being multiplied by that radical, so we're going to divide each side by the -1. 1 divided by -1 is -1, so we have -1 is equal to the cube root of 2t minus 3 squared. Get rid of that radical. Your index is 3, so raise each side to the power of 3. The radical and the power cancel each other out. -1 to the 3rd power is -1 is equal to 2t minus 3 squared. In order to get rid of that power, we have to take the square root of both sides. When you do that, you're taking the square root of a negative, which you cannot do. So this gives you no solution. So you would not work any further because you cannot take the square root of a -1 or a negative number.